Hey everyone, my name is Sarah Pollard. I know I've not met you in person. I'm here at my house. I'm gonna do the best I can to show you guys this micro lesson. And I don't have kids with me, so to kind of how you would engage the students and use this strategy. So this is a lesson for fifth grade science. Okay, it's the very intro lesson that you would do to start physical and chemical changes unit. So the teacher would engage the kids by asking, does anybody know what a physical change or a chemical change is? Have you ever heard those terms? The kids may say, oh, physical means somehow how something looks, or chemical is like chemicals you clean with, or things you shouldn't touch, they're dangerous, or a change means something's different. So whatever prior knowledge that they have, you're going to activate that. You're going to let the kids know that we're going to do two experiments. One is going to be for a physical change, and one's going to be for a chemical change. And after the experiments, and we've had a discussion on what happened in the experiments, we're going to create together an example of something called a Frayer model, which is a way to take a term that you're doing, give a definition, talk about the characteristics of things that are true, the traits of that term, and then draw and write in some examples and non-examples of that term. All right, so the first experiment we're going to show the kids is pretty easy to set up. You're going to have vinegar, just plain vinegar in a water bottle, or if you have a beaker, and then a balloon filled with baking soda. And you don't want the two to interact before you're ready for the experiment. So kids, I'm going to show you an example of a chemical change. I want you to observe the things you see as this chemical change happens. You're going to dump in that baking soda, and they're going to see those bubbles. You can walk around so they can all see a little closer, right? All that gas and bubbles, it fills up the balloon. They can feel to the touch that it's very cold, whereas before there was no temperature, it was very room temperature. And they can feel the cold down here, and they can see this filled up with the gas. All right. So you're going to tell them, guys, this was an example of a chemical change. Will you turn and talk about what things you saw that happened? Because we'll need that later when we do the Freire model together. And they'll talk about change in temperature, gas was produced, no longer you can kind of see some of the powder, but as those two things interacted, they created something new. And you want to guide them to get to that conclusion. Okay. So then you're going to tell them, hey, we have another experiment we're going to do of a physical change. Okay. And I want you to think, what things are you seeing me do that are different than what we did with the chemical change? And all you need for this, teachers, is, and you can have other things to show physical changes, but a real easy one, just need a piece of paper, scissors, something to write with. So you're gonna say, okay, this is a piece of paper. Okay. Nothing fancy about it. I'm going to rip this paper in half. Okay. I just did a physical change to this paper. And the kids might be like, really, that was it? Yeah, so what's different about this? You're going to get them talking about, well, it looks different now, right? You can see the rip down the middle, there's two pieces. This is a physical change because it's still made out of paper. You can get a different sheet of paper or you can take the same paper. You can fold it, right? You can fold it fancy, you can fold it normal. You can say, okay, what do you notice when I fold it? It looks different. I can unfold it. Look, now it's back to what it looked like before. I do have some lines in it, but it's still made of paper. You could show them the physical change with the paper by cutting, okay? If I'm cutting my paper, okay, it could be reversed, it could be put back together. It's an example of physical change. And then you could use a pencil. You could draw on the paper. This is not a pencil, but it helps if it is, because then you could say, I can reverse this and erase away the line and what I drew on. I can remove what I drew on it, and it's still made of paper. So you're getting the kids to realize that the physical change did not change the substance. Nothing new was created. It just looked different. All right. So once you've shown them the two experiments, you're gonna say, okay, everybody, I need you to take out on your desk is your Frayer model. They'll have an example of what you have at the whiteboard. And I'm gonna teach you guys how to create a Frayer model to take everything you just noticed and put it into this organizer that will help you later remember this term as we keep going in this unit. All right. So the first thing we're going to do in the very center, here's where you put the name of the term. So we just did physical change. Okay. So we're going to write that that was a physical change, remember, was the one with paper. All right. So you want to get them to create the definition. It's going to take some prompting because kids can be scared of definitions because they feel like they have to be textbook and they have to be very teacher lingo, or, like some you'd find in a dictionary. Doesn't have to be for this. I think it's great when they can come up with their own definition. So after they're talking about these things, you might come up with, okay, physical changes do not change. Okay, I'm kind of abbreviating so to say safe on time. Do not change the substance. By that, everyone, And again, this can be something as you call on kids, you together create this definition, but you want it to come from them for them to have some ownership. Okay. Does not change the substance, but it can change how it looks. Can change how it looks. Right. And once they've come together as a definition, you've discussed, you've written it, they read it in their frame under the definition portion. Then you talk about, okay, the characteristics are the things that will always be true about physical changes. So one thing like that is you're never going to create a new substance. Okay, the thing it's made out of after the change is still the same material. So no new substance. You can get the kids to talk about how it looks different. So the form might be different. A good example for physical change, if you didn't want to do the paper, would be an ice cube. And you can talk about this as well because it gives them the idea of how it changes the state of matter. Um, so with an ice cube, it's frozen water, right? And if I let that melt, it becomes liquid water. Can I take that liquid water, freeze it again, and still have an ice cube? Yes. And so you might say you can change the state of matter. So if you've already reviewed the states of matter by fifth grade, they already know them, but it's good to review them, solid, liquid, gas. You can give that as one of your traits. All right. For the examples and non-examples, a great thing about the Frayer model and working with your multilingual learners is that you can draw visuals. You can write words and visuals. So some examples, they might be like, okay, well, let's think of what we already did. So one of my examples might be cut paper. Okay. And I might draw a piece of paper and some scissors. Okay, cut paper, and it has that visual of that little drawing next to it. But you want to get them to come up with some other examples. So if you mentioned the ice cube, that would be an example of melted ice, or it could be melted ice cream, or it could be maybe not melted ice, but boiling water. Okay, that became a gas that could condense back down and become a liquid again. So you want to give a couple examples, and it helps. So that's my melted ice cube. Examples of in the Frayer model of the physical change. When you get to non-examples, this is going to clear up any misconceptions the kids might have. Okay, so they're working together to come up with, okay, well, if we want it to be non-example, it can't make a new substance. Let me think of something where it did make a new substance. And they might think back to the experiment we did where a new substance was created with the gas. So maybe a non-example could be if I put together vinegar and baking soda. Right? And you can draw your little balloon coming out of the horrible picture of it. Right. So they're going to draw their little image. You might say, okay, an example might be if I cut a piece of wood, okay, if I saw it in half, still made out of wood. But a non-example is like, what if I lit that wood on fire and I made a campfire? Does that create something new? And then I might say, yeah, it creates the flames. And then like after it burns for a while, it no longer is wood. Okay, it has turned to ash. So smoke and ash are new substances created when you burn wood. Okay, I can draw a picture of flames on a piece of wood. Okay, so you've filled out your Frayer model together. I'm trying to be good on time here. So after the experiments, after completing the Frayer model together, guiding them through with questions, they're going to move to guided practice where they are going to, on the other side of their paper, there'll be another Frayer model. They're going to do the same thing and work in teams, but to do it for the chemical change. So coming up with a definition, the examples, non-examples, and the characteristics. Now, very helpful would be to write on the whiteboard some sentence stems to keep that discussion going and kind of some scaffolds to help it move in the right direction. So I added some of those to my lesson plans. But it may be like, I think blank was a chemical change because I saw, you give them the options to say, I saw bubbles or smoke or a color change or heat produced. In this case, it's cold, right? And then another one could be, I think blank is a non-example because, so just small sentence stems to keep them moving in their conversation. All right, and as I wrap this up, so that would have been the end of the mini lesson that you'd be seeing me doing right now. They would do the guided practice of the Frayer model. You'd walk around, you'd kind of facilitate conversation if you're seeing them getting stuck. At the end, for the formative assessment, they would be given little cards. They sort in two piles. And the cards are cool because, and you can find them online, I've linked something to this as well, is it has little images as well as the words. So again, very visual, very hands-on. They're sorting them as a team, as a small group, into two piles, the physical change, the chemical change. That's your formative assessment that you're walking around and you're observing if they're putting them correctly based on these characteristics. They can refer back to the Frayer model, which is super helpful. And you're making observations and also correcting if they are putting them in the wrong pile by getting them to talk about, okay, remember, is it something new created or does it look different? Is it still made of the same thing? Can it be reversed? Those things are going to get them to understand the difference between those two. All right, and then the kids would keep the Frayer model definition is very helpful to look back on in their science notebook or binder or whatever you use for that. All right, I'm going to have my reflection on this lesson, excuse me, on a paper. All right, you guys have a good one.